If you're like me, you've started to see some glimpses of people expressing some skepticism about 5G and that it might be somehow damaging, cause cancer, or something like this. I wanted to make a quick video explaining how I am extremely confident that 5G cell data is not dangerous so that you can be extremely confident also. Maybe you're skeptical about 5G because people you trust think it might be dangerous. Maybe it seems like a conspiracy theory to you, but you don't know enough to prove them wrong. Hopefully this video helps. All right, the first thing to know is that all electromagnetic radiation is part of the same spectrum. And that goes from the radio waves that carry the music that you listen to in your car, to X-rays that you get at the dentist, and the visible light that we use to see everything around us. As we move from right to left in this spectrum, a photon of light, a photon of electromagnetic radiation, goes up in energy. These photons have a very high frequency. The light waves are oscillating really quickly and have high energy. Radio waves oscillate very slowly and have very low energy. So where do the 5G electromagnetic waves that carry 5G cell data lie on this spectrum? Well, somewhere in the microwave region. Sometimes they're called radio waves all the way up into this space. But it's somewhere in this region between 300 megahertz to 3 gigahertz, and then for some reason there's a break, and then from 30 gigahertz up to 300 gigahertz. So let's try to put this in perspective. Older generation cell data, including the 4G, which I'm still using, 3G and 2G, which we've been using for 10 years, is in a very close region between 700 megahertz and 6 gigahertz. All of this is in a giant region of the spectrum called non-ionizing radiation. That's very different from ionizing radiation. Some examples are the X-ray you get at the dentist. This is why you're very careful to reduce the number of times you get X-rays in a year if possible. And even more scarily, radioactive decay. This is the stuff that comes off the uranium in Chernobyl. And there's a fairly sharp delineation here in the UV region. UV light and above, a single photon has enough energy to break chemical bonds and to eject electrons off of atoms and turn them into ions. This can cause cellular damage, DNA damage, etc. Electromagnetic radiation in the visible region and below does not have enough energy. None of the photons are energetic enough to break chemical bonds or spit electrons off of atoms. Now, if an atom or a molecule gets hit by non-ionizing radiation, it can be absorbed and make it vibrate faster, which is what heat is. So non-ionizing radiation can still heat stuff up, but they cannot break chemical bonds or cause molecular damage. So let's get a little more perspective about where 5G is relative to other things we're used to. AM radio operates in the kilohertz region, as you might be familiar with. FM radio goes from like 88 megahertz to like 104 megahertz. Those are the exact numbers that you put on your radio, is the frequency of the radio waves you're receiving. So you might be able to see where I'm getting here. At least this band of 5G is definitely in the same region as other cell data that we've always used. But you might be like, what about this? This is a little bit higher energy. Well, there's lots of other things we use in this entire range of frequencies in electromagnetic radiation. GPS, TV broadcasting, which has been around for 70 years. All those TV stations coming through the air are in frequencies within this region. Old cordless phones, radar, Bluetooth, remote control cars, quadcopter drones. The signal that goes between the remote control and the drone is in this region. Now, if you're still suspicious that this band of 5G still seems to be on the higher energy end, first of all, we do have some things, millimeter wave scanners at the airport, some older types of Wi-Fi, radar guns are definitely in the same region, so it's not completely new. But here's the most important thing. There is so much electromagnetic radiation we get well above the 5G. Light bulbs, the little infrared LED on your TV remote control is spitting out radiation in the infrared frequency. Human beings, you ever look at a night vision camera or an infrared camera? Our bodies are constantly emitting infrared radiation. Sunlight emits radiation in the infrared region, the visible region, and as you know, some in the ultraviolet region, which is where you're getting into ionizing radiation, UVB and UVC, which can cause skin cancer, and tanning booths, of course. So by understanding the physics of radiation, I am not concerned about 5G because 5G waves are lower frequency than all of this other stuff that I'm exposed to all the time. If I'm not scared of standing next to a street lamp or a light bulb, There's no way I should be scared of 5G. And that becomes even more true when we talk about the power or intensity of any of this radiation. So on the spectrum, as we move from right to left, a single photon of radiation is more energetic. But you could also turn up the dial and put more energy out of any given wavelength. So we can talk about the relative power in wattage that you'd be exposed to. And this kind of comes back to my point I was saying earlier, that although this non-ionizing radiation cannot break chemical bonds, it can still heat things up. That's where microwave ovens come into play. A microwave oven emits microwaves in the region of around 2.5 gigahertz, which is smack in the same region, very close to 5G and other cell service. This is why if you put your cell phone right next to a running microwave, it can interfere with the cell signal. So let's talk about the total amount of power. Even if 5G can't cause ionization and break chemical bonds, might it still cause enough heat that could be damaging? The amount of electromagnetic radiation that a microwave puts into your food is around 800 watts. An old incandescent light bulb uses about 100 watts. It puts out probably less wattage than that in both the visible and infrared region, but it's still ballpark 100 watts. Modern LED light bulbs, which are much more efficient, use about 8 watts. So a 5G antenna at the top of a giant 5G antenna tower, that transmitter is putting out maximum of 120 watts. So if you stuck your head right up next to a 5G antenna, you climbed up the tower, stick your head right there, you're getting 120 watts of radiation of lower frequency than a light bulb. Now, let's say you're 30 feet away from the top of a 5G antenna. As you move away from a radio source, since that radio source is putting out energy in all directions, you only get a small fraction of it. And I did the calculation, 30 feet away, if this is putting out a total of 120 watts, in a 2 square foot area, maybe the size of a human head, you get only 2/100ths of 1 watt. Also, by design, cell phone radios, when they're transmitting out, have to put out, modern cell phones at least, have to put out less than 1 watt. So again, all of this cell phone radiation is putting out lower frequency, lower energy photons than all of this stuff we're exposed to all the time. The person sitting next to you is putting out orders of magnitude more radiation of a higher frequency, infrared, than your cell phone is. So to summarize, there is no possible way that 5G radio waves can cause ionizing radiation, could cause molecular damage, and there's no possible way that they could cause damage through heating more than these other things, which put out way more power and radiation of a much higher frequency than these radio waves. In this whole argument, this is all coming from first principles. I haven't even discussed any of the studies which demonstrate that radio waves are not harmful. Because first you have to have a baseline level of how likely is it that 5G causes damage. And based on these first principles, my baseline confidence is like 99.9% sure that there's no possible way 5G can be dangerous. And thinking through it this way is important because my level of confidence in my initial assessment determines how strong evidence has to be for me to change that. Because I have a very strong prior conviction that 5G is not dangerous, it would require very strong convincing evidence to convince me that 5G is dangerous. And there is definitely nothing convincing out there. All right, and the other thing, maybe this is an argument from authority fallacy, but like, think about your friends and family members who have the most physics education. The people that have taken college level physics or higher, who have the most understanding of fundamentally how electromagnetic radiation works, what are photons, what's the physics underlying all this. How many of them are concerned or sharing conspiracy theories about 5G? And I expect you'll find very few or none. I found none. So the people that have the most deep understanding of the physics of electromagnetic radiation are the least likely to be concerned about 5G. That should be comforting.